Okay, it's time to get started. Thank you everyone for joining our live lecture today. My name is Isaac and I'll be the lead instructor for the lecture. And today's topic is going to be web security. So, diving right in, let's go ahead and first talk about your mindset you should have as a developer in regards to security. Okay, so the mindset is prepare for the worst, hope for the best. Okay, so you should never build a program with a lackadaisical approach that, just no one ever is going to try to, abuse it in any way, right? You want to expect that to happen. Okay, so as well as that, you also want to take different measures and levels of security for different kinds of applications. For example, if you have like a mom and pop restaurant reach out to you and they say, we just need a static menu, that's all we need. Something like that wouldn't need a high level of security. But if they said we need a menu, but we also need, payment system and user accounts, well, then we definitely need to increase that level of security. Okay, so don't treat every app the same in the regards to how high of level security you have for it. Next, let's talk about developer accountability. Okay, so as a developer, you need to be aware that you are bound by certain laws when building projects within certain scopes. Okay, the two biggest being PCI compliance and HIPAA. So PCI compliance is the handling of credit card data. And the easiest way to stay PCI compliant is just to never let credit card data hit your servers. So how do you do that, you ask? Well, most of the time, developers are going to use a third-party service such as PayPal or Stripe, right, which is going to take care of all that for them. If you want to read up on the latest standards, you can go to PCIstandards.org. And then HIPAA is the handling of health data. Okay, so if you're working on a health app, you can come to hhs.gov and check out all the cybersecurity guidelines. Okay, and then make sure you don't let other personal information like social security card and driver's license numbers, all that fall into the wrong hands either. Next, let's talk about actors. Okay, so when you're building out your software, it's really hard just to think of all the bad scenarios just off the top of your head. So it helps to think in terms of actors. Okay, so for example, a good actor would be someone who uses the website for its intended use. Okay, that's like a customer. Whereas a bad actor would be maybe an internal employee who hijacks a customer's payment info, right? So if we think about it in that scenario, we're going to build our software in the way that our internal employees can't hijack customer payment info, right? So that's just one scenario, but build around actors, and that tends to help you guide your way. Okay, next let's talk about trust boundaries. Okay, so trust boundaries are divisions between areas of software that have different privileges. Okay, and these are different for all different kinds of associations and groups, but there's some pretty standard ones. Okay, and those are client-server roles, network machine boundaries, encrypted channels, authentication, and areas of responsibility within a system. So let's go ahead and go over each of these. Okay, so first we'll start off talking about a computer network. Okay, and if you don't know what a computer network is, it's simply a collection of computers connected by a transmission medium. When you write software for the web, it'll end up being hosted on a web server. And then clients can connect to your server via web browsers, phones, apps, or anything capable of sending a request. Okay. Next, let's talk about encrypting channels within your own network. Okay, so anyone in the same network can actually view all the traffic that you're sending and receiving. So in order to have a private conversation between clients and servers, the channel must be encrypted. So this can be accomplished by using something called a TLS certificate and redirecting your web traffic from HTTP to HTTPS, and the S stands for secure. Okay, so there are many providers out there you can use, for TLS, but two of the biggest ones are going to be Symantec. Okay, so here's one, and another big one is Comodo. Okay, excellent. All right, so now that we've seen where we can access those, let's go ahead and now talk about API security for our specific endpoints. Okay, so because endpoints are generally publicly exposed, it's a good idea to set up some additional logic to verify the incoming API requests. Okay, so if we go to github.com, we'll notice that when we're a guest, before we've logged in, GitHub allows us to view public resources, right? But we can't view any of our own resources. So as soon as we log in and we're an authenticated user, then we can view the public and the own resources. Okay, and if we have a role for administration or organization, we could access those special privileges as well. Okay, but you see how GitHub doesn't just allow any guest to access any resource, right? And in this way, they're securing their APIs from being abused. Next, let's talk about imposing a rate limit on your API. Okay, so by imposing a rate limit, we can ensure our site won't get attacked with several requests at once. Okay, so GitHub's another great example of this. They have a rate limit already set up for their API. So let's go ahead and send a request and see what we get back as a response. So when I send that off, I can see that it lets me know that my rate limit started at 60, and now I'm down to 59. Okay? And again, this is because GitHub doesn't want me to hit their endpoint with thousands of requests at once and bog down their servers, right? So by setting up this rate limit, I can, as one individual user, can never do that. Okay? So that being said, let's go ahead and talk about the DOS attack. Okay, so the denial of service attack is simply accomplished by flooding the targeted machine or resource with many requests at once in an attempt to overload systems and prevent some or all requests from being fulfilled. Okay, so this is again what GitHub has in place, right, to prevent this from happening. So that way they don't have a DDoS attack. Okay, preventing this, we can use a couple different things. Okay, so throttling is one, so we can limit the bandwidth that's used. Rate limiting is another. Okay, the number of requests that can hit an API endpoint in a specific time amount. And then our web traffic monitoring tools. There's a dime a dozen out there, so you can really take your pick on those. But they just will show you, really unusual spikes in traffic, so you can take preventative measures if needed. Next, let's talk about a different kind of attack called an XSS attack. Okay, so cross-site scripting is a type of computer security vulnerability typically found in web applications. XSS enables attackers to inject client-side scripts, typically through an input of sorts, into web pages viewed by other users. Okay, so to prevent against this, we can use something called sanitization. Okay, and basically, it's going to check your input for the type of data. If it's not a string or a number, right? Some valid type. If it detects that it's a script, it's not going to allow that input to go through. Okay, so there's a lot of sanitization libraries out there for all the different kind of programming languages. So definitely utilize those as needed. And now let's talk about another kind of vulnerability, okay? SQL injection. So SQL injection is a technique used to attack data-driven applications. So those are applications with a database. And so how it works is they take SQL statements and they insert them into an entry field for execution. Okay, and what this allows the attacker to do is run different statements so that they could dump the database contents back to themselves. They can do a lot of bad stuff. So to prevent against this, we can use sanitization, right? Again, to make sure that these don't get through, even though SQL statements are so close to plain English, right? We could still filter those out with sanitization. And also we can use tools called object relational mapping. We won't get into really what that is now, but you can definitely check it out if you're looking for extra security layer for a SQL application. Next, let's talk about file uploads. So one of the most commonly exploited web vulnerabilities is unrestricted file uploads. So this can allow an attacker to upload an executable file, such as a PHP file, and then call the corresponding URL from their browser. They are now running code on your server, okay, which is really bad, right? They can pretty much do anything at that point. So to prevent against this, we can use something called a file type detector. And this is just basically going to check for, JPEGs or, PNGs, right? Certain specific types of files. And if those types of files are present, then it'll be okay. But if other kinds like a PHP file, right, or a Python file, right, try to get uploaded, then yeah, this file type detector is going to let us know. Okay. Next, let's talk about ARP spoofing. Okay, so ARP spoofing is a technique by which the attacker spends a spoofed address resolution protocol message into a local area network. Generally, the aim is to associate the attacker's MAC address with the IP address of another host, such as a default gateway, causing any traffic meant for the IP address to be sent to the other attacker instead. Okay, so this is very much like an interception. Okay, and this is why it's important, within your network to use a TLS certificate and redirect your traffic from HTTP to HTTPS. All right. Another kind of spoofing is called DNS spoofing. Okay, and DNS spoofing is where a corrupt domain name system data is introduced into the DNS resolver's cache, causing the name server to return an incorrect IP address. This results in any traffic diverted to the attacker's computer. Or it results in traffic being diverted to the attacker's computer. Okay, so again, this is like an interception of sorts, except it's more on the DNS provider you're using to prevent against this. And these are very less common because DNS providers tend to have very good security. Okay, so to prevent to prevent against this, we can use the TLS certificate. Okay, so I'm sure you're seeing a common pattern here, right? Many of our prevention methods bring up the TLS certificate. Okay, so this is really something that is not worth skipping in any kind of professional application. You really are going to want to invest and make sure you have one. All right, so moving right along, let's talk about a firewall. So a firewall is a network security system that monitors and controls the incoming and outgoing network traffic based on predetermined security rules. It's always a good idea to make sure that the machine your server is running on has one set up. Okay, so more than likely if you're working at a company, the managers, right, they're going to take care of all that. But if you're working on your own application for your own clients, right, that kind of stuff, you're going to want to make sure firewall is set up to give your application the best security possible. All right, now let's talk about having a plan B. Okay, so like we mentioned in the beginning, prepare for the worst, hope for the best. But at the end of the day, no system is completely 100% secure. Not even the FBI or CIA, right? You even hear of those guys getting hacked, right? So it's a good idea to always back up your data and operating system in case of emergency so your service isn't interrupted for your end users, okay? Especially if you have a business, right, that runs through that software. As well as having those backups, you should also have an emergency checklist in place in case of a service outage so that the corrective action can be taken immediately upon discovery of the issue. Okay, so oftentimes with these attacks, time is everything. So the longer you let it, go unattended, the worse the issue gets. Okay, so by having one of these checklists in place for not only yourself but your team members, this is going to allow you to mitigate the issue much quicker. All right, next let's talk about organizational privileges. Okay, so as there's oftentimes a large number of hands involved with building a single software project, it's often a good idea to restrict access to things on an as-needed basis. For instance, a developer may have access to modify the code, but not to touch the production servers. And the operations team might have access to modify the server environment, but not the code. Okay, and this all comes down to the fact that everyone's human, and we all feel emotions and make rash decisions, based on those emotions. So if you have an employee who got fired or is quitting, right, and it's their last day on the job, they might decide to go into a database for that company and just nuke it, right? And that, could really cause problems. So make sure, within your software team, right, that you don't just have everyone have access to everything, because that's really a recipe for disaster in the event that the employee wants to take advantage of your system at a later time. All right, so make sure, you hand those out carefully. Next, let's talk about protecting passwords. Okay, so there's several ways of protecting passwords. Let's just start there, okay? There are several programming languages, several approaches. Okay, so the approach we are going to be talking about is hashing. Okay, so when encrypting passwords, we first add what's called a salt, which is a long random sequence to our password, and then we run a hash algorithm on it. And the hash algorithm is used to verify that the block of content has not changed. And so this does two things for us. First, it makes it nearly impossible to guess the password without knowing the salt. And second, even if the attacker gains access to the salt, they won't be able to use the pre-computed hash tables to get the passwords out. They'll have to compute the entire space from scratch. So, in a nutshell, we're never going to be storing our actual physical password in our database, okay? Because if someone gains access to our database, they're going to be able to get into all of our user accounts. So what we do is we are going to encrypt a password hash and a salt, and we're going to save those in our database, and then we could just use those combined with the real password to determine if the person who's trying to log in is indeed the authenticated user. Okay, so as well as encryption, it's also a good idea to enforce some sort of password strength rule. Okay, so we've all seen these, right? You have to have a minimum of like 6 characters, or maybe it has to have an uppercase letter, or whatever you want. But it always helps to give it one extra layer in that regard. And the main reason is you don't want easy guessing, right? Like most people, right? Or most websites, right, are going to have one user who has a password, which is password, right? And that's an easy guess for like a hacker. And they even do brute force attacks where they'll run thousands of passwords just to see if they can, get the right one. And so if your users have easily guessed passwords, more than likely your software is going to get hacked at some point. So add this little extra step, and that can go a long way. Next, let's talk about two-factor authentication. Okay, so the one factor is just when we enter an email password, right? Nothing to it. But then two factors, like where they would send a code to your phone or a different device, right? And you would have to enter that code to continue, right? And that's what's considered two-factor authentication. And it increases the difficulty for the attacker because they would have to compromise more than one device in order to successfully impersonate a user. So, for example, if I was riding the subway home, right, and on my way home, I was really tired, and I left my laptop on the subway, right, and I got off, and it gets picked up and stolen, right, and so now the person with that laptop logs in, and they have autocomplete, right, and they're able to log into a lot of my accounts, and so when they go to try to log into something like my bank account, the bank account asks them, all right, we're going to send a code to your phone, and you've got to answer that. And now they're stuck because they only have your laptop. They don't have your phone too. So that makes it really hard for them to get that, full, abuse underway. So next, let's talk about some places that we can go and keep up to date on the latest vulnerabilities and what we can do to prevent against them. Okay, so some of the top resources. This first one is a government-maintained database called NVD. Okay, so you can come here and check out their vulnerabilities, all that great stuff. Protect yourself accordingly. OWASP is another one. Okay, so it's more like a Wikipedia for incidences and that kind of thing. And then we've got Verus, which is a database, similar to MBD, but it's community instead of government. Okay, so yeah, make sure you are keeping up to date, and you're not that developer who software gets hacked, right? That's the last thing you want on your reputation. So take the time, do your research, get involved with the community, security community, and make sure that you don't fall victim to the vulnerabilities we discussed today. All righty, so it's a lot of information. Let's go ahead and open up the floor, and let's see if anyone has any questions about what we went over. Okay, so the floor is open. If you have questions, feel free to ask them now. Okay, nothing today? All right, well, if that's the case, thanks everyone for coming. Have a great day, and happy cyber security.